So in this sum, we have our Z0 is 50 ohms. The length of the transmission line is given as 41.6 centimeter. The dielectric constant is 2.49. Frequency is 500 megahertz. Z impedance is 20 plus J25 ohms. So you have to find ZL and VSWR again with Smith chart. So now if we go to find our ZI, what we need to locate ZI, we need this small ZI, which is equal to ZI divided by Z0, which we get as 20 plus J25 upon 50. So if we calculate, we'll get it as 0.4 plus 0.5 J. Okay, J caps or whatever J. Now first thing we do is we locate our 0.4 plus 0.55 J. So it is plus, so it would be above the above the x-axis. So now 0.5. So let's locate our 0.4 and 0.5. So this is my 0.4 and my 0.5 is somewhere around 4 and 6. So this must be 5 and 0.4 and 5. And that is exactly where the point lies. Okay, let's just confirm it again. It is 0.4 plus 0.5. So this is 0.4. So the bigger circle, and the 0.5. So these lines. So I can read it from here. So this is 0.5. So I connect it over here. Now next step is we connect it with the center of the circle. So now if I extend the line from this, okay, at this point we will check at which point does this line cut the towards generator axis. Now why are we interested towards towards load axis? Why are we interested in towards load is because what we have given here is we have been given ZI is given and ZL is not given. So this is a transmission line. So now we have our Z input impedance. So now we want the output impedance. So we have to go towards the load of the transmission line. So now when I'm going towards the load, so this is my wavelength towards the load, I will locate it is around 0.417, I guess. It is around 0.417. So it is, let me recheck it, 0.4142, and it is around 0.417. Okay. Now the next step is how do I find ZL? Of course, that is the next step. In between, we can find out our VSWR. So now our VSWR would be this circle. This is a constant VSWR circle. A circle wherein the VSWR says constant. But to locate it, we have to locate it on the x-axis, the positive direction. If we see, this is our VSWR. So our VSWR is 3.2. So this is, if you just check, it is 3.2, around 3.2 VSWR. Okay. So we already have one parameter over here. Now we need the ZL parameter. Now for ZL, we again are going to solve. So for ZL, what we need to find is we need to find the length in terms of lambda. Okay, so as we know in Smith chart, these all quantities are in terms of lambda. So to find it in terms of lambda, what we need to find is first the value of lambda. In the previous sum, we already had the length in terms of lambda. Here we have it in terms of centimeter. So we have to find the lambda in terms of centimeter and then divide. So we know that lambda is equal to V, that is the velocity of the wave, upon the frequency. So now V is the question mark. So our velocity of a wave is basically c, that is the speed of light, upon under root k, which turns out to be around 190 117.275.157. Oh, these are too much in decimals. Okay, now so if we just calculate, our lambda would be V upon 500 megahertz, 5 into 10 raised to 6, which would be equal to 0.38 meters. Remember, the term that you get is in meters, converted into centimeters because our length is given in centimeters. So it is 38 centimeters. Okay, so all we have to do is divide our length by the lambda. So length is 141.6 centimeter divided by lambda, 38 centimeter. We get somewhere around 3.726, somewhere around that number. Okay, now 3.726. okay. Now we go on to the next thing, which is, so now I know my length is 3.726 lambda. I have to locate it on my Smith chart. On my Smith chart, I have to locate 3.726. So this is my length from the input side. So I have to go towards the load. So where's my load? Okay. So I have to go 3.726 in this direction. So from 0.417 I have to go 3.726 times. So what I'll do is basically the point where I have to where I have to reach is the load plus 0.417, right? So we'll just add them for our calculation safety. You can just even count it, but that's not practical. So when we add it with 0.417, the actual point to be located is at 4.141. Okay, so now if you go to check on the line, there is no 4.411 because the maximum it can reach is 0.5. So what we do is basically 4.411 or 4.413, I guess. Okay. So the maximum we can reach is 0.5. So imagine if you have a line that is a transmission line, so a wire that is basically wrapped around this circle. So it's in turns, right? So it would be 0.5, then it would be 0.1, and then it goes on 1, then 1.5, 2. So basically the point I need to locate is 143, sorry, because the 4 times I will be revolving around the Smith chart, and my final point will be 0.143. So which I would be getting 0.1. So this is 1.4. So around this point. And let me just check it again. Wavelength towards load. No, this is not the point. .2, 23, 24. Sorry for that. This chart is a bit messy. So this is where my point I have located, 0.413. I'll connect it to the center, and I instantly get my ZL. Now my ZL points would be 0.7 and 0.955. Now since it is below the x-axis, it is minus and j whatever. So this is my ZL. So my final ZL actual load impedance would be Z0 into small zl. So that would be around 35 minus 47.75 ohms. So I've already got my ZL, and our VSWR we got was 3.2. So finally got the solution.